Okay, hi everyone. This question is about the reactions of haloalkane with the sodium hydroxide form the alkenes. And this question we can consider the structural isomerism and stereoisomerism. Okay, so it started with colorless liquid C5H11Cl. And this one exists as a mixture of two optical isomers. Okay, here it's telling us that this compound has one chiral center. Okay, when heated with the sodium hydroxide in ethanol, okay, which is elimination, so a mixture of two alkenes is formed. Okay, so a very important thing before you proceed is you must understand the elimination is happen when there is the hydrogen on the adjacent carbon. Okay, the carbon that with chlorine, so the adjacent carbon, okay, it must have the hydrogen. So therefore the hydroxide can attack this hydrogen and it will form the CC double bonds later because CH bond break here. The electrons can move here to form the double bond and the CCl bonds break. Okay, then it's formed chloride. So it will form three major products, the alkene, H2O, and the halide. Okay, so the important point is the elimination, it must happen, okay, when the halogen or the chlorine in this case, so is removed, okay, with the H, not really form HCl, the H here will form H2O, the chlorine will form chloride. Okay, so the key again is the adjacent carbon must have hydrogen. Okay, so A, with the formulas given looks something like this. From here we know that no chiral carbon in this molecule, so answer, okay, this is not the answer, so it's out. Now for B, from the structural formula that provided, so we know that this carbon is a chiral carbon, so it has one group, two groups, three groups, and four groups, right? Okay, so this can be considered now, and the chlorine, okay, will remove, okay, together with another H. Okay, so this chlorine can remove with this hydrogen. When this chlorine is removed with this hydrogen, then is formed this alkene, and it's just only one. When this chlorine removed with this hydrogen, it will form this alkene. This alkene can form cis trans because this carbon and this carbon in the CC double bond, it has two different groups. Okay, this ethyl group and this H and this methyl group, right? So it can form cis trans. Okay, but in this question is asking only two alkene, so now total is 3. That's why B cannot be the answer. Okay, C. If we try to draw the structure clearly like this, we know that all the carbons, they are not chiral carbon. So no chiral carbon, that's why cannot be considered. Okay, of course, answer is D. Okay, if you draw nicely, so something like this one. So we know that this carbon is chiral carbon. This is chiral carbon because it has 1, 2, 3, 4 different groups bonded to it. Okay, and this molecule also will undergo elimination. This chlorine can remove with this, okay, to form this alkene, or this chlorine can remove with this hydrogen to form this alkene. Okay, these two, okay, this carbon has two same group, cannot form cis trans. Okay, and this carbon has two hydrogen, also cannot form cis trans. That's why it can form two alkenes only. So answer confirm is D. Thank you.